Hello, welcome to Astronomical Observation. So this is continuation kay chapter 2, which is Geodetic Astronomy. So we discussed the concept of Geodetic Astronomy for you to have an idea what is the use of the astronomical observation. So basically, ma-determine natin yung position ng ating line or ang reference line mismo, yung ating true meridian by the use of astronomical observation. Yung ating mga traverse, pwede natin siya ma-reference in true meridian. We can determine the true bearing and true azimuth of your line. So, the determination of the azimuth of the line, pwede tayong mag-observe ng sun or star to determine the azimuth, or kung kailangan natin yung latitude, we can perform a stellar observation in which yung Polaris yung ating i-observe. So, let's discuss this one first. So, the common problems in surveying which employ the knowledge of geodetic astronomy is identification ng ating position in terms of the latitude, longitude, and the azimuth. Siyempre, yung ating longitude, we can determine through the difference in time. And yung ating azimuth, pag nagsasurvey tayo, ito yung ating if we are not using the advanced instrument, just like the RTK, or wala tayong mga reference point na kailangan natin i-observe, kailangan natin in reference yung ating line, in the absence of reference point, so pwede nating i-employ ang astronomic surveying or yung ating solar observation. In latitude determination, so meron tayong dalawang method. It could be culmination determination through a culmination or through the transit of the body. So we have the four cases in which the lower culmination and the upper culmination. When we say lower culmination, nagko-culminate yung ating star in which nag-pass by siya sa ating zenith and the north celestial pole. So pag lower culmination, yung ating star ay below kay north celestial pole. And nag-upper culmination siya if yung star natin is above kay North Celestial Pole. So in this, as you look in the illustration, si star ay nandito sa baba ni North Celestial Pole. That is a lower culmination. And here in the case 2, yung ating star ay located taas kay North Celestial Pole. That is upper culmination, north ni zenith. North na siya ni zenith because andito yung ating zenith. So, lower siya kay zenith, north of zenith. So, in case 1, you can determine the latitude of the observer by subtracting the value of the altitude. Yung ating altitude is this one. Yan, from horizon to star, that is the altitude. And yung ating polar distance is the distance from the North Celestial Pole to the star. So, yung ating latitude is from horizon to our North Celestial Pole. So, pagkuha natin yung sum ni H and P, na we can now determine the value of your L. In the case 2, we have here, pag upper culmination north of zenith, okay, no need to memorize the formula. You just need to illustrate and you can now determine the latitude of the place. Meron tayo ditong altitude. So, from the altitude again is measured from your horizon to star. That is the horizon. And yung ating polar distance is from star to North Celestial Pole. And yung ating latitude is from horizon to ating NCP. So, para makuha natin yung ating L, you just subtract the H minus P. You can use the other formula also, which is the declination. Saan ba yung ating declination? Yung declination natin is from the equator up to this one, the star. That is letter D. And yung ating Z, that is from zenith to star. So, yung ating value ni latitude, pwede natin siya makompute by L equals to yung ating latitude minus P. So, makukuha natin yung ating latitude. So, D, yung ating declination minus the Z, we can now determine the latitude of the place. Okay? Yung latitude of the place is this one here. Nakikita nyo? So this is the latitude. So this is just similar kay this one. This is from equator to zenith or north celestial pole to horizon. So that is the latitude na ng observer. Okay, let's go next to the next case. Meron tayong upper culmination south ni zenith. So yung ating upper culmination siya because north pa rin siya na north celestial pole. South of zenith because nandito na yung ating zenith and yung ating star is lower na kay zenith. So, andito yung ating zenith and si ating star, lower na siya. So, south mismo siya ni zenith. So, if we're going to determine the latitude, yung ating 90 minus h plus d, yung ating h, ito yung altitude ni star. Yung ating d is declination, that is equator to star. So, pwede natin ma-compute si letter ang latitude by 90 degrees minus h plus d. For the case 4, upper culmination, south ni zenith. South pa rin siya ni zenith because andito yung ating zenith sa baba at sa taas. And nasa baba yung ating star. Upper culmination siya because nasa area ng North Sea, Sea star. So, the same formula, we have 90 minus h plus d. Okay. So, for example, meron tayong have here latitude determination. For example, they compute the latitude of the place of observation when the observation of Polaris is at upper culmination. So, kailangan mo lang first, kailangan you get the mean muna of the altitude. Meron tayong observation, the direct and the reverse. You get the mean and you draw. So, upper culmination siya, I guess, the declination is 89 for 20, which means yung kanyang declination is north na kay zenith. So, this is upper culmination north of zenith. So, you determine the latitude of the place of observation. Okay? For the time computation, so the astronomic observation can be used to determine the apparent time or yung ating mismong time using a certain method of computation. So, by means of the cosine formula, nada-derive na natin simula kay PZS triangle. Diba? Yung cosine H natin, similar na yun kay cosine T, yung R angle. So, yung sine H, dyan is, yung H is the altitude, sine latitude, sine of declination for the gamma, cosine latitude, cosine ni declination. So, pwede na tayong gumamit ng ibang formula, yung naka-half angle din. Okay? So, for the azimuth determination, nag-o-observe tayo ng star para ma-determine natin yung azimuth ng line. So, the azimuth determination given the declination of the body from the almanac. So, meron kasi tayong tinatawag na almanac. So, ito yung the almanac records the daily movement ni sun around ecliptic. So, makikita nyo yung kanyang right ascension is increasing from May 1 to May 31, di ba? Yung right ascension because yung ating right ascension is increasing counterclockwise from, di ba, nag-start yung ating right ascension pag-measure kay vernal equinox. So, by vernal equinox 0, that is March, April, May. Pagdating niya kay May, so di ba may value na siya 2 hours, 34 minutes, and 35 seconds. So pagdating niya kay declination, na-observe mo siya declination, di ba 15, nagtitika-increase siya hanggang maging May 31. Because pagdating niya ng June, 'di ba summer solstice at June 21. So mare-reach niya yung pinaka-highest or pinaka-peak na declination ng sun which is a positive 23 degrees in 30 minutes. So pagdating niya ng March, June, pinaka-highest siya which is 23 yung declination. June, July, August, September, nagtitika-decrease na liwat niya. Balik siya pag 22, 21, 20 until ma-reach niya September. For the month of September, so the declination siya, mabalik niya pag 0. And pag abot niya kay for September, October, November, December, mag-start na pag negative ang mag-start na pag-negative ang declination until ma-reach niya ang pinaka-lowest declination which is negative 23 degrees 30 minutes ha December. And mabalik ulit niya pag-increase pag January, February until ma-reach niya ang March. Okay? So for the azimuth determination again, so the azimuth determination from the solar observation are applicable only to project control surveys o yung maliliit lang ng mga control surveys. So if for geodetic surveys, we need na to conduct, we need to use the GPS na. So for kung example nagsisurvey ka sa malayong area and walang oray mga control, existing control, hindi ka maka-connect ng referensyo, you conduct a solar observation because yung azimuth na nahukompute mo is a true azimuth na ng line. As long as the data and you perform the survey or the solar observation well with accuracy. So equipment needed, kailangan mo lang ng theodolite or total station na may solar eyepiece, range pole, and calibrated watch or mas better yung ating cellphone yung ating gagamitin. Okay. So if you are going to conduct a solar observation, yung kailangan lang ng data natin i-gather is this one. So again, yung purpose ni solar observation is position determination. So yung data na kailangan natin i-gather is the zenith angle o yung altitude ng sun. The horizontal angle, this is the angle measured from your reference line to the position of the star and the time of observation. So, the correction to be applied, bakit tayo nag-a-apply ng correction? We will discuss on the next slide. Si refraction, ito yung refraction, parallax, index error, semi-diameter, and the hourly variation. Yung pang-apat, we have here the refraction, parallax, index error, and semi-diameter. Ito yung correction na i-apply lang natin kay altitude. So, si altitude lang ang kailangan nating applyan ng correction sa refraction, parallax, index error, and semi-diameter. Yung ating hourly variation, we need to apply correction on the declination. So, di ba yung ating table ni Almanac is naka-daily yun, daily changes. So, we need to determine the hourly variation of the sun, yung declination niya or ang ating north polar distance. So, yung ating domain by refraction, bakit kailangan tayong mag-correct ng refraction sa ating na-record na altitude na sun o yung vertical angle na nababasa natin kay instrument? So, refraction is caused by the bending of light. Imbes na yung ating actual position ng sun, yung ating nare-read because light bends. So, yung apparent position ng sun, kasi apparent yung ating nakikita mismo, but the actual is much lower yung ating position ng sun. So, we have difference in angle. Imbis dito lang dapat, ini lang dapat nga angle, ang nababasa nato is ini nga angle. So, may dakita error nga di. So, this is the correction that we need to apply on the altitude. So, this value is always minus because nga, ang atong nababasa nga altitude is greater. So, we need to apply, this is subtracted. Next, for the refraction is this one. Si parallax. Si parallax naman, this is applied because the altitude of the sun should be measured with respect to the center of the earth and not on the surface. So, pag nagkakonduct tayo ng solar observation, wala naman tayo sa center ng earth, andito lang tayo sa surface. So, we need to correct our position. So, we need to apply parallax correction. So, in which, yung parallax natin is always plus. It is applied sa ating na-observe ni altitude. If we are going to combine the correction for parallax and refraction, so the correction is always minus because refraction is much larger than the parallax. For next, we have the index error, which is applied also in the altitude. This is the error in the instrument vertical circle. Pag sineset natin yung vertical circle into 0, so hindi siya actually to the infinite na 0. So, it needs to be correct, especially pag ginagamit natin in theodolite. So, So this error of instrument is remedied by subtracting the index error of the vertical circle to the value of the vertical angle of the celestial object being observed. Okay? Next, the last one nga we are going to apply for correction sa ating na-measure na altitude is the sun semi-diameter. So, we only measure at the side of the sun which is supposed to be at the center, pero hindi naman natin na-identify kung saan yung center ng sun. So the measurement may be taken more accurately on the edge, kaya gumagamit tayo ng tinatawag na tangency method. So, in the tangency method, tinatangent natin yung sun at sa edge to determine its center. So, pag tangency method ang ginagamit in conducting a solar observation, no need to correct for sun semi-diameter. Okay? So, this is in hourly variation. Again, this is applied sa ating, this is applied to our declination or the north polar distance of the sun. So, this is corrected to the declination of the sun. The correction to be applied for MPD is just the difference in hour times your hourly variation. So, what do you mean by difference in hours? And this one, ano ibig sabihin ng difference in hour? Ano yung ating hourly variation? When we say difference in hours, ito lang yung mean time. When we say mean time, ito yung average time ng observation in one set minus yung 8 a.m. or 2 p.m. So, it depends kung morning nag-observe during solar observation, then you are going to subtract the time by 8 a.m. So, pag afternoon naman, you need to subtract the time for 2 p.m. So, in the land survey manual, say, the required time in conducting a solar observation is from 8 a.m. to 10 a.m. And for the afternoon observation, we have 2 p.m. to 4 p.m. So, yung hourly variation, para natin nakuha, this is tabulated from the ephemeris table. It is in second per hour. So, nasa ephemeris table ito. So, therefore, yung ating corrected NPD is just the NPD plus yung ating correction. So, nama-minus lang siya if negative yung declination ng ating sun. Okay? So, ito yung field procedure and how are we going to conduct the solar observation step by step. So, here we assume that we want to determine the astronomical azimuth of your T1 and T2. So, mag-establish tayo ng T1 to T2 where yung T2 natin is may given na yung coordinates. So, i-set natin siya as ating control. So, magsiset up tayo ng instrument at T1. Then, backside kayo kay T2. Isi-set natin yung ating horizontal angle kay T2 to 0. Tapos, i-turn natin yung telescope until sa direction kung saan makikita mo si sun. And yung telescope mo, i-direct mo siya sa sun. There, you can read the horizontal angle and the vertical angle of the sun. And also, records the time, records the altitude, and records the horizontal angle. So, with the telescope in a direct position, when you say direct position, nakaharap sa, yung instrument mo is nakaharap yung telescope sa sun. So, sight the sun at its first position and record the horizontal circle reading, yung time, and the vertical reading. So, much better kung ginagamit natin na Geodetic digital para mas madali yung pag-record. For number 4, on the direct position, the sight on the sun at its second position. Tapos, reverse naman at the third and fourth reverse position. So, don't forget again to record your time, horizontal, and your vertical reading every observation. So, dalawang set yung dapat, set 1 and set 2. Set 1 is dapat, yung isang set is composed of 4 observation, the direct, and reverse. In which isang set, composed siya for 10 minutes. So, in one observation is 2 minutes maximum. And set 2 is the same, 10 minutes gihap. So, all in all, set 1 and set 2 is 20 minutes. That is equivalent to one series. So, with the telescope still in reverse, you continue to take the second set of reading. So, meron akong illustration para mas madali. In the next slide. So, ito yung set 1. We have the direct, reverse, reverse position ng sun. Ito yung makikita nyo sa this one. Ito yung makikita nyo sa paper na ilalagay natin sa eyepiece ng telescope, reflection ng sun. So, bawal natin tingnan yung mismong sun. So, kailangan natin ng paper para makita natin yung reflection ng crosshair and then projection ng sun. Set 1 and set 2 are 10 minutes and 10 minutes. So, all in all, that is 20 minutes. So, dapat every observation may interval na 20 minutes na 2 minutes per observation. So, have here a sample. So, meron tayong T1 kung saan natin we set up the instrument here. So, we have T2 kung saan yung ating control. So, if you turn the telescope on T2, so you need to lock the horizontal circle and set the horizontal reading to 0, 0. So 0, 0. Then turn the telescope to the position of this sun. Okay? And that is now your horizontal angle. So pag igbaw naman, namabasa natin atong vertical angle, or that is the altitude of the sun. But if you're using a total station, ang nababasa ni total station is the zenith angle. So you need to convert the angle to the vertical angle. For set 1, diba set 1 is direct, reverse, reverse. For set 1, direct, that is the first quadrant. So you need to synchronously record the time, horizontal angle, and vertical angle. This is for set 1 direct, ikaduha nga direct, nasa third quadrant, reverse na pod, first quadrant, second quadrant, and the third, and the fourth reverse, we have the fourth quadrant. So that is equivalent to one set, your direct, reverse, reverse observation. So all in all, that one set must not exceed 10 minutes. For set 2, another 10 minutes, continuous siya. So that is reverse, reverse, direct, direct na. So once na-reverse mo na, and for the set 2, that is reverse, reverse, direct, direct. So following the same quadrant, and the same sa set 1, only that is reverse, reverse, direct, direct na. For the computation, so prior to the start of the observation, this data must be obtained first. We have the magnetic azimuth of the station to mark. You need to determine the magnetic azimuth. You can either use a magnetic compass para ma-determine kung asan si north, para ma-orient nyo yung position ng inyong station. We have the latitude of the place of observation. You can use your cell phone, your Google Map, your Google Earth. Can display, you can give you a latitude of your place of observation, the temperature during the observation. Anyway, you can use your cell phone, elevation of the place of observation, the meridian of the place, the date of observation, exactly the date and the hour, index error of the instrument used, especially if you are using the theodolite or the transit. So different values needed for further computation will have to be referred from the following tables of publication. So yung parallax and refraction, you can get this in the ephemeris table, which is available in internet. You can search. So the following values will have to be determined. This is in step by step na kailangan yung i-determine the azimuth of the sun. First, kailangan natin i-compute yung mean horizontal angle from mark to sun per set and per series also. We have mean vertical angle to sun, a mean time at a place of observation, because we're going to use this in computing the declination. GCT, when the observation was made, yung oras mismo. We have the sun's apparent declination, the date of time of observation, so makikita natin sa almanac, the true altitude of the sun, ang corrected na kay refraction, corrected na kay index error, and so on. We have the azimuth of the sun. If makukuha na natin si A, B, C, D, E, and F, now we can compute the azimuth of the sun. And in such a way, we can compute also the true bearing of the line. So this is a sample format of the table that we need to fill up in conducting a solar observation. Yung direct, reverse, kung anong quadrant, quadrant 1, quadrant 2, 3, and 4. So yung oras mismo ng pagbasa, yung horizontal angle reading, zenith angle, and the vertical angle. So meron tayo, they have here a computation, sample computation to in the setup na nagkakandak sila ng a solar observation. Compute the azimuth of T1 to T2 using the nodes of solar observation using a wide field of light by a tangent method. So, nag-tangent method sila, no need to correct for a semi-diameter correction. Okay? Yung station 1, we have station 2. Yung nag-occupy sila sa T1, observe sila sa T2. Yung latitude ni T1, that is the latitude of the place of the observation, which is 143340.73. Yung initial horizontal circle reading niya ay 0, 0, which means naka-zero lock yung kanilang telescope kay T2. The date of observation, meron silang here, north polar distance at that instant of observation, the day. We have the 69, 39, 26, 40 hourly variation, which means nag-i-increase yung oras, nag-i-increase yung declination natin every hour up by 29.64 seconds. Correction of parallax and refraction, I guess hindi siya combine. Yung ating 56 is for parallax. I know, yung 56 is for refraction. And yung ating parallax is 55. Because always greater yung ating refraction. Okay? So, data gathered on the field. So, ito yung kanilang data na gathered. Meron silang oras. So, first quadrant, we have 8:32:07. This one. The horizontal angle. So, I guess, ginagamit nila is a digital theodolite because naka-zenith angle pa yung kanilang angle. So, this is the direct, reverse. So, as you can see, yung angle ni direct and ni reverse. So, direct, so 48 lang. Yung mga reverse is 300 plus because binaliktad mo yung telescope. Okay. Yung next, we have the reverse. So, reverse. Pangalawa, the direct and direct. So, para differentiate nyo kung naka-reverse na ba yung inyong telescope, you look at the angle kung the same ba or hindi. So, first thing to do is you're going to compute the mean time, mean horizontal angle, and the mean vertical angle. So, kailangan natin muna i-identify yung mga vertical angle. So, we have the mean time, yung mean horizontal angle for set 2, and mean vertical angle. So, we are required to compute the corrected altitude for set 1 and set 2. Diba? Kailangan natin i-compute yung corrected altitude. Determine the corrected NPD. Compute the true azimuth of T1 to T2 and compute the probable error. So, paano natin masasabi na yung ating ginawang solar observation is accurate or pasok sa standard ng DNR? So, we need to compute the probable error. Okay. So, sa data na gathered, I have here the solution na. So, this is 48. Yung 48 natin, zenith angle man siya. So, minus 90 para makuha natin yung ating vertical angle. The same, this one. The same, minus 90. So, 311 degrees, 50 minutes, 43 seconds. Paano natin ma-determine yung vertical angle, that is minus 360 degrees, 270. So, this one also. So, yung mean vertical angle niya is 4128, 3.25. So, the same goes through the set 2. So, to solve the corrected vertical angle for set 1, Diba? Vertical angle, which means yung ating altitude. So remember this, altitude of the sun should be corrected with the parallax and reflection correction. So, mean corrected altitude is the main altitude plus yung ating parallax minus sa ating refraction. Okay. Corrected altitude is 41, 28, 3.25 plus yung ating parallax. Okay, yung parallax talaga niya is 56. Okay, ipapollow na lang natin yung problem. We have 55 ang kanyang refraction. So, yung ating corrected altitude is now 41, 28, 4.25. So, walang in-indicate na may index error. Walang naka-indicate na may iba pang correction. So, this is now the corrected altitude. So, take side naman, we can use this in computing the azimuth of the star. This is for number 1. Ito na, we compute the mean. Isasamo lang siya. This is the average divided by 4. We have the horizontal angle also. So, this is direct. Naka-reverse pa itong 178. So, kailangan natin i-determine yung reverse, yung kanyang direct na value. So, 178, 19, 54, 44, minus mo lang siya plus mo lang siya ng 180. Okay, you plus 180. So, to determine the direct value. So, ito yung 179,0225 plus mo lang 180. So, now you can determine na the direct value. So, yung ating zenith angle, we have now the mean horizontal angle. Meron na tayong mean vertical angle for set 1. This one is for set 2, for set 3, and for set 4. You check if the solution is correct. So, paano natin masosolve yung azimuth ng line? So, determine the azimuth of the sun muna. So, before we determine the azimuth of the line T1 to T2, first we're going to determine the azimuth of the sun. So, we can use the following formula. If you remember, the same lang to sa ating cosine Z that we derived in PZS triangle. So, the same lang to. This is a half angle formula. So, where your P is the corrected north polar distance, your H is the corrected altitude, L is the latitude of the place of observation, and your S is the the half angle. P is your polar distance, H, that is the altitude, L, the latitude over 2. Okay. So, paano natin makorek yung ating value ni north polar distance? Again, yung formula niya is just the corrected north polar distance, the north polar distance plus the correction. How can we get the correction? So, how am I going to correct the value of the north polar distance? So, the corrected north polar distance is just the polar distance plus your correction. Your correction is hourly variation times your difference in time. So, the hourly variation, that is the amount of change of the sun's declination per hour. So, may given tayo. So, the difference in time, i-minus lang natin yung mean time natin by 8 a.m. for morning observation and minus 2 p.m. for the afternoon observation. So, yung given natin na polar distance which is 69, 39, 26.40 plus yung ating hourly variation na 29.64 seconds per hour times yung ating difference in time which is 8 a.m. minus the mean time. So, yung answer is 32:50:75. So, therefore, your NPD, corrected NPD, yung ating difference in time, it should be in hours. Siya, kailangan natin siya i-convert in hours. Yung 32 minutes, 50.75 seconds is equivalent to 0.5474 hour. Just to cancel out the hour. So, the remaining will be in seconds. So, the correction for NPD is 69:39:42.63. Okay? So, to solve the azimuth of the sun, you use this formula. So your S is PH plus L over 2. So your P, that is the corrected polar distance, the corrected altitude, and your latitude. So your S now is 6250, 4318. You double check my solution, please. And the azimuth. So if you substitute the values on the formula, you can get the value of A, which is equals to 104 degrees, 27 minutes, and 27.99 seconds. So if this is the azimuth of the sun, how are we going to compute the azimuth of line T1 to T2? So let's draw. How are we going to determine the azimuth of line T1 to T2? So yung ating azimuth ng sun is 10, 27, 30 from south. So this is not yet the final azimuth of the sun. So the azimuth of the sun, that is 360 minus A for morning observation. So hindi pa yan yung A. So if you're going to, for the afternoon observation naman, yung A mo, that is now the azimuth of the sun. So in this problem, yung observation is ginawa in the morning. So the azimuth of the sun should be minus with 360. Since morning observation, yung azimuth na sun is 360 minus 104 degrees, 27 minutes, and 27.99 seconds. Therefore, yung ating azimuth ng sun is 255, 32, 33.01 azimuth yan from south. That is the true azimuth of the sun. Okay. So to determine the azimuth of the line connecting T1 and T2, you need the following. Kailangan natin yung ating mean hour angle. This is the average hour angle that we read for set 1 and set 2 and the azimuth of the sun. And computing the azimuth of the line, so if the horizontal angle is measured clockwise from T2, so the direction of the sun is, if this is T1, so yung ating azimuth, this is the direction, the azimuth of the sun from south, yung ating unang angle. This one, that is the horizontal angle. Ito, this is the horizontal angle. Salatan natin, horizontal. This is the horizontal angle. Horizontal angle of line T1 to T2 to the star. And yung ating first, this is the computed azimuth of the sun. Itong ating first na angle. So, to determine the azimuth of the line 1 to 2, so this 1 to 2, so ito lang. So, yung difference ng angle, so you get first this angle and plus the azimuth of the sun, that is this this angle here, that is 360 minus the mean horizontal angle, plus your azimuth of the sun. You can now determine the azimuth of the line from T1 to T2. Okay? So this is the end for this presentation on solar observation. So I guess on December, before the January, I will give you the complete lab guide for solar observation. So we're going to conduct solar observation in this subject. Okay, the rest. So the next presentation will be the positioning. And by the way, I'm going to give you a video on the conduct of solar observation for your reference. Thank you.